Hi and welcome back. In this video, I want to talk briefly about converting from standard form to vertex form of a quadratic function. So there are actually multiple ways to do this, but the way I'm going to teach us how to do is by graphing. So I'll talk a little bit about the other methods you might learn in a different class, and then we'll talk about how I do this with graphing. So I'm not going to go into too much detail here, I just want to mention these things in case you are watching and you've heard of them before, or if you go look at some other videos or other texts and you see these referenced. So the first is called completing the square. I actually really love completing the square, I find it really fun, I think it's a cool puzzle, but it's really not used that often. So as an actual skill, it's not super useful, and in my opinion, if you ever need to complete the square, you can probably learn it pretty quickly. So we're not going to learn it right now. It's really kind of tedious. It's a process you sort of learn how to repeat over and over again, but it's not super useful, and I found that students often just find it very confusing and unnecessary. Then some teachers also just use a formula in order to help find the vertex. So this formula would be that the h value is negative b over 2a, and the y value is f of that value, negative b over 2a. So you really can just take the right numbers and divide them in this certain way. But personally, I see this as just something that you have to memorize or look up every time you need it. So if all we're going to do is memorize, I think we might as well use some graphing tools instead. But if you see someone else doing this, just know that this is a valid way. I just think you can also do this effectively with graphing. So let me show you what I'm talking about. Okay, so we're going to do two examples where we convert to vertex form. So first, let's convert the function to vertex form, where we're starting with f of x equals x squared minus 6x plus 10. So this is in standard form, ax squared plus bx plus c, and we want to rewrite it in vertex form, a times x minus h squared plus k. Alright, so without doing any other work, we actually already know our leading coefficient, our a. So the a value stays the same between standard and vertex form. So our a value is going to be 1, since we have that 1x squared in standard form. So we already have our leading coefficient. Then, in order to find the vertex to put into the form, I'm actually just going to graph the parabola using technology. So for me, that looks like Desmos. I really like just opening up Desmos quick on my computer or my phone and typing in the function. So let's type in x squared minus 6x plus 10 using Desmos, and we can see as soon as it graphs it, it's pretty clear to identify the vertex. So I see the vertex is at the point 3, 1, and Desmos will actually let you just click on that and confirm that that's what the vertex is. So our vertex is 3, 1, which gives us the h and the k value. So the h value is 3, and the k value is 1, and now I can put these into the formula. So a is 1 times the quantity x minus h squared, so for us that's x minus 3 squared, and then plus k, so plus 1. So this is my final version in vertex form. I'm just going to clean it up a little bit, and I'm going to write f of x equals x minus 3 squared plus 1. So there's a lot of math you could do in order to get to this place, but how fast was it just to graph the function and then find the vertex? So if you needed to do this, I think the fastest way to do it would be to just graph it and find the vertex. Those other methods can be fun or interesting, and you could totally learn them if you need them. I completely believe in you to do that, but this is as complicated as I want it to be. Okay, let's try this on another example. So let's convert the function to vertex form if we have h of x equals negative 1/5 x squared minus x plus 4. So this is written in standard form, ax squared plus bx plus c, and we want to convert it to vertex form, which is going to look like a times x minus h squared plus k. So similar to the last example, the first thing we can do is find a, since our leading coefficient stays the same. So here our a value is negative 1/5, and I'm just getting that from the original function in standard form, looking at that a value, the leading coefficient. Now we need the vertex, h and k, so we're going to graph the parabola in order to find this point. So in Desmos, I've graphed -1/5 x squared minus x plus 4, and the vertex wasn't as clear to see, so I just selected it. So Desmos already had it available for me to pick, and it's given me the coordinates that are -2.5 and 5.25. So I'm seeing the vertex is that point, and from here I have my h and my k. So my a value is -1/5, we had that already, and now I know my h value is -2.5, and my k is 5.25. And now we just put them in the formula. So I'm going to write this as g of x equals -1/5 times x minus -2.5 squared plus 5.25. And I don't really like that minus and minus, and so I'll rewrite this as -1/5 x plus 2.5 squared plus 5.25. And there we go. Alright, so that is how we are going to convert from standard to vertex form if needed, just by graphing the function in Desmos, identifying the vertex, and writing it in the correct formula. That's it for this one. Thanks so much for watching, and I will talk to you in the next one.